In today's video, I want to talk about integer conversions between variables of different sizes. So here I have two variables defined in my program. I have a short int that the values might be a bit complicated, but it's actually just 2 to the power of 14. And we have an int, a simple 32-bit integer. And I noted down here how much each one actually takes up in memory. The first one is actually 2 bytes, and the second one is 4 bytes. So makes sense, right? When we're trying to run this, it's just going to print on the screen both the values, right? First is x, and then second is y. And I'm just using this. HD means a short int for our printf format, and d just means a simple int, as you might know. Okay, so both of them are powers of 2. Now, what happens if I try to assign to the value of y the value of x? So y is larger, so you should be able to contain the value of x in here. So if I try to say y equals x and try to run this, you'll notice both of them get the same value. And that's correct because, well, y can actually store any value of x. But how does that happen behind the scenes? Well, here x in binary is actually the simple string 0, 1, then followed by 6 zeros, and then a byte that's just 0. Right? That's just how 2 to the power of 14 is represented in binary. Simple enough. And since we know that they are the same number, we actually have the same number here in y after we assign it. But since it has to have 4 bytes, it has to pad some bytes to the left. So what C does in this case is take a look at the sign bit and says, oh, it's 0. Well, I'm going to pad it with zeros. So I'm just gonna copy and paste these 0 bytes here, and then we get our result. That's how y will look in memory after we assign it, right? So we get both the same number. Now, what's going to happen if we actually have a negative integer? If we have here negative 16,000, what's the difference? So, since this number is 2 to the power of 14, to change this one into a negative number is very simple. We just have to change this to a 1, the sign bit to 1. That's it. That's just in this case. In most other cases, you should do more than that. But this is a special case where you don't have to do anything else. So now we have a negative number with the sign bit equal to 1. If we try to run this, you'll notice that it also works. We get the same result. Both are negative 16,384. But inside memory, we actually don't get the same result. We don't just change this one to a 1. What C looks at, it says, okay, well, I want to expand this into a 4-byte integer. To do that, I have to take a look at the sign bit and copy and paste it everywhere in the padding bytes that I have to add. Right here, I have just 2 bytes. I have to add 2 more to get 4. Right, so it's going to add basically 2 more bytes full of 1s at the level of binary. So I'm just going to get 1 of there and 1 of there, and that's how y is going to look like in memory after we assigned it. Right. It's going to pad with 1s instead of zeros because that's what the sign bit is in this case. Now let's try the reverse. Let's try assigning the value of y to the variable x that is smaller, right? So we have a large variable that should somehow fit inside our smaller one. How's that gonna work? Well, if I say here x equals y, I'm just going to assign it, right? So I'm just taking the value of y and assigning it to x. If I try to run this now, you'll notice something interesting. We're actually going to get, well, y in our case is this second number, and that's correct. We're still getting that 2 to the power of 30, but the first one, which is x, has now become 0. Why is that? Well, there's a simple explanation. That's called trimming. Whenever we have to fit a larger number inside a smaller one, we're actually going to get the first few least significant bytes and plop them right inside our variable, our smaller variable. So in our case, we have 2 to the power of 30. How do you represent that in binary? Very simple. So the first bit is actually the sign bit, which is 0. The second one is the 30th power of 20, which we know it has to be 1 because it's 2 to the power of 30. And then the rest is just zeros because it's exactly 2 to the power of 30, right? I'm just gonna copy paste this so that it's not getting too tiresome. Okay, so now we know that this is how y looks inside memory. But how are we gonna fit this number inside x? Because remember, this guy has 4 bytes, but x doesn't. It only has 2 bytes of memory. So what C does in this case is it doesn't take these 2 bytes because that wouldn't make any sense, right? You would get the 2 most significant and you would get a very strange number. So this guy is gonna take the first 2 least significant bytes from our y here, which are basically these 2, really resulting in the operation of what is called modulo, right? What this is going to effectively do is assign to the variable x the value of y modulo, and that is a bit more complicated, but it's actually modulo 2 to the power of however many bits you have inside the variable you're trying to assign. Basically, well, we have 2 bytes, right? Each byte has 8 bits, so that's equal to 16. What's 2 to the power of 16, you ask? Well, it's actually 65,536. So what do we get actually? Well, since this number, this 2 to the power of 30 actually perfectly divides to 65,536, we get no remainder. Thus, this operation resulting into 0. So we get these 4 bytes inside our x, which are, you guessed it, exactly 0. If I were to, for example, add 1 to this number, so instead of 2 to the power of 30, it would be 2 to the power of 30 plus 1, then we will actually get not 0, but, well, 1. Because the first bit, this one, would have been set, and this is how much it would be copied inside our x value. And that's about it for this video. I hope you got something out of it. You remember that when expanding variables, we actually take the sign bit and copy it everywhere we have to pad the larger variable with when assigning it. And when we're trying to assign a smaller variable in size, we actually trim the first least significant bytes from the larger value. Thank you guys so much for watching. Leave the questions down in the comments below or on our Discord server, and see you next time. Take care. Bye.